Hello everyone, welcome to this video number 7 or the last video for module 2. So we'll kind of wrap it up with the remaining topics here. So before we go ahead, let's look slightly into normalization. So if you noticed, here we have performed some normalization, right? So we used or subtracted the mean from each value in the data frame and divided by the standard deviation, right? So this is also called standardization. And when we do z-score or normalization based on standard deviation, we usually look into plus minus 3 standard deviation to detect the outliers. Similarly, we can do max-min normalization. So max-min normalization, right? So for the max-min normalization, let's create a data frame. So I'm going to call a data frame housing data frame number I think 6. Yep. Equals to housing data frame dot copy. So that will copy the data frame. So once we copied, remember there's one um, attribute remodel which is of type category. So we will not be able to apply any mathematical operations on that. So let's drop that first. So housing data frame 6, drop, we want to drop remodel, and in place is going to be true, and axis equals to 1. So we drop that. So that's good. So once you dropped the required column, now we can declare a new data frame. So I'm going to call it max min norm, right? So just to keep the values for max min normalization. And for max min normalization, to put this in perspective, so we take the value, each value, and we subtract the minimum value from that, and we divide it by range. So range is always maximum value minus minimum value. So let's get housing data frame 6, and we will subtract housing data frame 6 dot min, right? So subtract the minimum value from each attribute, and we will divide it by housing data frame 6 dot max max and minus housing data frame 6 dot min, right? So that should be good. Yeah. So we subtract minimum value from each value and divide by its range, right? So let's print it out. So max min norm dot describe. So here we go, right? So here's the maximum norm describe. So maximum value is 1 and the minimum value is 0. So when we do the maximum normalization, so what we're trying to do, we're trying to scale everything from 0 to 1. The minimum value will always be equated to 0. Remember here what we're doing, we are subtracting minimum value from the housing data or a given value in the housing data frame. So as you subtract a minimum from minimum, it's going to come to 0, right? So the minimum will always be 0. Maximum will always be 1, right? So we're trying to rescale everything on 0 to 1, right? So that's about the maximum normalization. So the next thing we want to look into is duplicates. Okay. So duplicates, it's just easy. It's not very difficult for duplicates. So let's declare a variable. So I'm going to call a variable duplicates or dupes. And in housing data frame number 6, we can use a function duplicated. So what this will do, this will compare every single row with each other, right? And if there's a match, if there's a duplicate, it would return a true value. If it's false, if it's not duplicated, it will return a false value. So what you can do is you can do dupes.sum. So if you do this, it's going to print out the false returns, the true returns. So which means whenever we encounter a duplicate value, so we have a true return, and in sum, we are simply adding those true values. So in this particular data set, we have 3 duplicates. So usually what we'll do, we'll go ahead and remove those duplicates, right? So before we do any removing, so let's look into housing data frame 6 dot shape. So we have 5,802 rows, right? So in which 3 are duplicates. And the other thing, sometimes you may wonder, okay, hang on, what are those indices, right? So those index values. So again, we can check the duplicate index as well. So dupes, so that's where we're storing the duplicate reference. So dupes equals to true. So again, it's the conditional selection. So instead of selecting from a data frame, we're selecting from an array here, right? And let's return the index. So let's print out dupes index. Okay, sorry, dupe index. So we have row number or transaction number 1179, 3895, and 5228. So those are the duplicates. So how do we remove it? So let's remove the duplicates. So in this case, we'll do housing data frame 6 equals to housing data frame 6 dot drop duplicates, right? And so that will drop the duplicates from the data set. And let's do the shape again. So let's see if those 3 values are removed or not. So your new shape or number of transactions, we have 5,099. Initially it was 5,802, right? So those 3 duplicate rows are removed from the data set, right? Okay, so next let's look into the discretization. So what we want to do here is we want to convert a continuous variable to a categorical, right? So it's very similar to like you create bins in a histogram, right? So let's demonstrate this. So in housing data frame number 6, we have number 6. Let's say we want to look into total values, and we want to do value counts. So value counts. So if you do this, I mean, there are in total 2,747 entries. So which means there are 8 entries or 8 transactions for which the listing price is $410,000. 8 transactions for which the house price is $354,000. So now I'm not going to look into these many categories, right? So it's better if I perhaps have 10 bins or 5 bins based on your analysis needs. So what you can do is you can define a bin size for the continuous variables. In this case, total value is a continuous variable, and we can say bins equals to 10. So what happened with this, we have converted this into a categorical variable, right? So very first bin size is from 218.56 to 385.1, and they're in total 3,143 houses which are listed within this price range. Then for the next price range, we have 2,195 95 listings for this particular one, and so on, right? So it's very useful, especially to reduce your data by converting into a categorical variable, right? So the next thing, let's look into one more, which is called grouping. So before we do grouping, let me just add one more note here. So when you do discretization, let's say you're working with the categorical variable. For that, you don't need to define the bin size. For example, in this particular data set, data frame, I think we don't have remodel here, but in an initial data frame, we have the remodel. And for value counts, you don't need to define the bin size. We already have the categories, right? None, recent, old, and so on, right? Okay. So again, grouping is again used to reduce the data set size by grouping data based on certain categories, right? So for example, what we can do here is, let's say we want to group data by remodel. So we can create a new data frame. So let's say I'm going to call it group by category. And let's use our original data frame. So housing data frame. And so we'll use a function is called group by, and we will define group by remodel, right? And then we need to define a function, what we want to do with the data. So what is going to happen here behind the scenes is going to group all the transactions, let's say for the recent category, but now we need to aggregate that, right? So what we're trying to do is try to do some kind of aggregation. So in this case, let's say we want to aggregate it by average. So let's print out group by category. So as we execute this piece of code, so you can see here, instead of having transaction number in this particular data frame, we have remodel as a category based on which we are grouping rest of the attributes, right? So the average total value for the price for the houses which are recently remodeled is $446,000, which are remodeled old is $405,000, right? So we'll explore group by a bit more as we go through data visualization chapters, but try to apply this based on some other attributes such as total value. Or the other good one could be, I think there's one full bath, right? So let's use that. Remodel, instead of remodel, we're going to use full bath. So here we go. So we have kind of, so this is the outlier, we already know that in the housing data frame. But there are 5 different categories, right? And which total value, tax, and all other attributes are grouped and aggregated based on the average value, right? Okay. All right. So let me show you one more thing because it kind of becomes more interesting. So what you can do, you can group by based on multiple attributes as well. So I want to group by full bath, floors. Let's pick up 2. We want to display the average value. So let's execute this. So now you can see it is kind of further categorized. So we have full bath category. Then within full bath, we have different houses with different number of floors, right? And their average value, average tax, average lot square footage size, and so on, right? So it depends on your analysis what dimensions you want to explore for your data set, right? So please explore this. Try to use multiple group by options and different aggregations here, right? So the next thing, let's look into correlation analysis. Okay, so for the correlation analysis, so very first thing, why it is important that you want to do the correlation. So let's say you want to apply some of the regression models. So for the regression models, you don't want to have a high degree of correlation or a high correlation coefficient between independent variables. Otherwise, it will lead to the autocorrelation issues, right? So we want to avoid that. So in those situations, we want to kind of have a quick peek at the correlation between the different values or the independent variables we have, right? So in this case, let's look into housing data frame, and we can use the function is called correlation, CORR, and let's round it to 2 because otherwise there will be too many decimal places. So now let's say we want to predict the total value based on these independent variables. So as we look into the tax has a very high correlation with gross area, with living area, right? Similarly, lot square footage has a very high degree of correlation. No, actually not. So here we go. Gross area has a very high degree of correlation with the living area. So we want to drop the variables or the independent variables which has a very high degree of correlation, right, when it comes to the regression analysis. We'll kind of come back to this again in the subsequent chapters, but this is kind of one way to have a quick peek in case you need to drop anything else before you start with the analysis.